Good morning, calc fans. How we doing on this fine Friday morning? Little dreary outside right now, but the weatherman said it's supposed to get nice and be around 60 degrees. So it gives us an opportunity to be able to get outside again today if you want. I was going to go over a couple problems from your worksheet from yesterday. Then I have a couple additional problems I posted online that we will go through. Nobody has requested anything, so I will just pick a couple out of here and go through a couple problems. Take a look at problem number 4. Since we always love our trig ratios or our trig values, we have the antiderivative or integral of 7 sine of x minus 3 cosine of x dx. Now, we will take the integral of each individual part here. And once again, these are things you're going to put to memorization. What are some indefinite integrals or antiderivatives for certain functions. We have our exponent rule, but then we have our early transcendental functions also. If we take a look at 7 sine of x, 7 is just a coefficient, so we don't really worry about that. We have to look at what is the antiderivative of sine. The antiderivative of sine is negative cosine. Antiderivative of sine of x is negative cosine of x plus c. Antiderivative of cosine of x is equal to sine of x plus c. So it is opposite to what we have with respect to our derivatives. And because we're doing the antiderivative, that's what we should expect. So we take the antiderivative of 7 sine of x. The sine of x is negative cosine of x, so we have negative 7 cosine of x. Then we take the derivative of cosine, which is just going to be sine, so we have minus 3 sine of x plus c. And that's it. If we take a look at problem number 6, we have the antiderivative of 9 over x squared dx. So we're going to transfer this into a form that we can deal with. So we have the antiderivative of 9x to the negative second dx. Now once again, if I'm going too fast, hit your pause button, and it'll slow me down a little bit, and you can catch up. So looking at our exponent rule, once again, our exponent rule, if we have ax to the nth dx, we add 1 to our exponent, and we take our coefficient and divide by this n plus 1. So typically people or students will look at and do this. Look at the exponent first, add 1, so we have negative 1 there, and we're going to take the 9 and divide by the negative 1, and don't forget your plus c. So we have negative 9, x in negative first, plus c, x in negative first. Once again, I will ask you to simplify radicals, put it back in the radical form, and eliminate all negative exponents. So what this will turn into is negative 9 over x plus c. We take a look at problem number 10. The magic of YouTube videos is if it is going too fast, you can always push stop and replay it. You can't do that when I'm actually teaching. So it's sort of a nice thing for you with respect to YouTube videos. Number 10, we have the antiderivative of the 4th root of x cubed dx. First, we had to take a look at 4th root of x cubed. We need to put this into an exponential form. So we have the antiderivative of x to, this is my numerator, 3. This is my denominator, 4 dx. Once again, what people will do is they'll add 1 in that manner. So we have x to the 7/3, or 7/4. And then we have to, should I give myself a little bit more room there? take our 1 and divide it by our new coefficient of 7/4. All this tells us to do is to reciprocate. So what we're left with is 4/7, and then we could probably go back to this one right here and say this is x to the first times x to the 3/4 plus c, which will then give us 4/7 x 4th root of x cubed plus c. Or if I want to change this to 1 3/4, this is 1 3/4, so we have x to the 1 times x to the 3/4. We take a look at 13. Yeah. Problem 13, we have the antiderivative of 6 over, let's see, cube root of x dx. Once again, the differential tells us what we need to use our exponent rules or our rules for. So we have to first write this into an exponential form. So we have the cube root of x, which is x to the 1/3. It's on the bottom, so we can take it up top. So we can rewrite this as the antiderivative of 6, x to the negative 1/3 power. Once again, this would be x to the 1/3. And to take it up top, we just threw the negative in there. dx. We add 1. Now, the nice thing about adding 1 is this takes us to 2/3. So we have x to the 2/3 power, and then we have 6 divided by the 2/3. Once again, 6 divided by 2/3 is 6 times 3/2. This will give us 1 and 3, so we have 3 times 3, which is a value of 9. And then we have the cube root of x squared. And don't forget your plus c. If we look at a differential equation, we've done one like 16 already. Let's do number 17. We have dy dx is equal to 4x minus 7. And we have an initial condition of 1, 5. So separating our variables, multiplying both sides by dx. We have dy is equal to 4x minus 7 dx. To get rid of our differentials, we have to take the antiderivative, the differentials and the antiderivatives, get rid of differentials. If we take the antiderivative of dy, we get y. We have to take the antiderivative on the right, so we add 1, so we have x squared, and then 4 divided by 2. Remember, with a constant, we just tag a variable along, and then once again, don't forget about your plus c. That's the whole idea of what we're trying to do. We're going to solve for the c. So we have y is equal to 2x squared minus 7x plus c. We now have this initial condition here. Here's my x and here's my y. So we have 5 is equal to 2 times 1 squared minus 7 times 1 plus c. And now this allows us to solve for c. So we have 5 is equal to 2 minus 7 plus c. This gives me negative 5. I add 5 over. So we have 10 is equal to the value of c. Once again, don't leave it just as this. You want to rewrite y equals 2x squared minus 7x plus 10. Once again, if I'm going too fast, hit pause, that will slow me down and also shut me up. Okay? So I won't be offended if you turn it off and you try to catch yourself up. I posted 2 problems for us to go over today. The first one puts it just into a different perspective. The slope function of the tangent lines for a graph of a function is defined by m of x equals 6x plus 5. If the graph of the original function, f of x, contains the ordered pair 2, 8, determine the function f of x. Now, how does this relate to what we just did? Well, we have to go back and ask ourselves, how do we determine the slopes of tangent lines to a function? That's a thinker. That's exactly right. We took the derivatives. So when I look at this function here, the m of x function, m just symbolizes a slope. This is the slopes of the tangent lines, 6x plus 5. But what we did to find them, this is also our derivative. This is dy dx. So for this function, the dy dx of this function is defined to us as 6x plus 5. And what we want to determine is we want to go back and find what is our original function, f of x. Well, if dy dx is equal to 6x plus 5, we now have a differential equation with this initial condition. This is my initial condition, 2, 8. So we're just solving a differential equation. It doesn't change. It's just the verbiage that goes along with it is changed a little bit, but really we're doing the exact same thing. So we can separate our variables. dy is equal to 6x plus 5 dx. To get rid of our differentials, we can take the antiderivative. So this would give us y is equal to, let's see, my new exponent is going to be x squared, 6 divided by 2, plus 5x plus c. So we have y is equal to 3x squared plus 5x plus c. And what we have to do is solve for c. Well, we're given the value, initial condition of 2 and 8. Here's my x and here's my y. So we can sub in 8 is equal to 3 times 2 squared plus 5 times 2 plus c. Just how we got to this was just a little bit different, but we're still doing the same thing. So we have 8 is equal to, let's see, this is 4, 12, this gives me plus 10, plus c. This is 22, so I can subtract 22 from both sides. So we get a c value of 22 minus 8, which is negative 14. So my original equation then, once again, is going to be y is equal to 3x squared plus 5x minus 14. So it allows us to go from the slopes of tangent lines back to what my function really was. A second set of differential equations. Given f double prime of x equals 6x plus 8, f at 1 is 5, f at 2 is 12, determine f of x. Well, what we have here is now we have the second derivative. And I'm asked to find what my function is. Well, to get rid of my derivatives, we have to antiderivative, but if I antiderivative the second derivative, all that's going to take me back to is my first derivative. But if I do this, I have f prime of x is equal to, my 1 is there, I'm going to add 1 to it, so I'm going to have an x squared. Then 6 divided by 2 is a value of 3. I'm hoping that you can handle that now. Plus 8x plus a value of c. Problem is, I have two initial conditions for my original function, 1 and 5 and 2 and 12. But this is my derivative still. So to get to my original function, we have to take the antiderivative one more time. So my original function f of x is equal to adding 1, x cubed, 3 divided by 3 is 1. I have a 1, so I'm going to add 1, so I'm going to have x squared, 8 divided by 2 is a value of 4, plus cx plus, and I'm going to throw in a d in there. What we have to do is now solve for two variables, c and also d. But I had two initial conditions. If I have the ordered pair 1 and, 1 and 5, that's my first ordered pair. What this gives me is this gives me 5 is equal to 1 times 1 cubed plus 4 times 1 squared plus c times 1 plus d. So we have 5 equals 1 plus 4 plus c plus d. I just picked numbers out of my hat, and this is what we came up with. So we have, this comes down to 5. I'm going to subtract 5. So what we're left with is 0 is equal to c plus d. Now we have two variables we need to solve for a second equation. Two equations, two unknowns, it's systems of equations. So if we take a look at our second order pair, which is 2 and 12, this would give me 12 equals, let's see here, 1 times 2 cubed plus 4 times 2 squared plus 2c plus d, because I have put a value of 2 in there now. So this gives me 12 equals 8 plus, let's see, 2 times 2 is 4, 16, plus 2c plus d. This gives me 24, so we'll have to subtract 24. And what we are left with is negative 12 is equal to 2c plus d. Once again, we now have two equations and we have two unknowns that we have to solve the system of equations. Bringing this down, we have 0 is equal to c plus d. And we could do any method. We could do substitution. What I do is I usually do elimination. And these eliminations, you can eliminate a d real quick. So if I multiply through by -1, we have negative, negative, and negative. Now if we add down our values, what we are left with is negative 12 is equal to c, and the d's go bye-bye. So c is equal to negative 12. This then will lead us to 0 is equal to c plus d. So c is negative 12 plus d, adding 12 to both sides, d is equal to a value of 12. So my function going back to what I came up with, my function f of x is equal to x cubed plus 4x squared. Then we have c times x. C is negative 12, so we have minus 12x. And d we just solved for is 12. So this is my original function. I've posted another worksheet that involves sort of like a review for a review over Newton's method and also indefinite integrals and differential equations. Please work on that this weekend. Monday will be a review day, Tuesday will be a quiz. Wednesday and Thursday of next week will be reviews for the chapter test over the entire chapter 4, and then Friday we will have chapter 4 test. Once again, the University of Findlay is requiring us that we continue with lessons and continue to go through the material, so we will continue to go through this material. If you have any questions, once again, please email me any of your questions. Hopefully the videos are helping you out and trying to understand some of the material. But please continue to work on the lessons as we go through the lessons. If you have any questions, feel free to email me. I hope all is going well in your house. I hope everybody's staying sickness free. I hope you're staying sickness free. If you get a chance, go outside, get a little fresh air today. It was nice the last couple days to be able to get outside and do some work on the outside. Other than that, please make sure you just once again keep up with the material that we're going through. If you have questions, email me the questions, post any comments that you want. And once again, we'll continue to push through this. Continue your practicing of social distancing. Hopefully that will get us back to some sort of normal as quickly as possible, so we can get back to actual classroom settings again. I miss you guys. I wish you were around, but I understand this is the best for all, and that's all we have to do. Is it's a little inconvenient, but it's the best for all of us. But if you don't have any other questions, like you would have any questions, please email any type of questions. Hope you have a good weekend. Stay safe, stay out of trouble. Get yourself some Double D ice cream. There we go. That'll work. Adios. Have a good weekend, everybody.